Good day, everyone. So today we shall be diving into gear drive systems. Gear drive transmit motion between shafts and are crucial for various mechanical applications. They are fundamental component in machinery and enable precise control over speed and direction. Okay, so the major work of gear is to transmit motion from one shaft to the other. It's a powerful system for transmission of motion. Okay, so let's look at this in details. Like what we call the jet train. A jet train consists of two or more gears merged, as you could see in the diagram. Combination of two or more gears. Looking at the diagram here, see now that this form a train. The green, the blue, and the red gear together form a chain. Okay, and as they clock on each other, that process is called matching. The match that will match together. Okay, so in jet train, the key concept you must know is that it transmits motion between gears, within the shaft of gears. Okay, that's one key point about jet train: transmission of motion between the shaft. Number two, it is important to keep lubricating the gears to prevent wearing off. And thirdly, it is important that the teeth of the gear are uniformly spaced. Very, very essential so that the motion can be smooth. Alright? Now, there's what we call seizure in gear and also directional control. Gear, as you could see here, you see that it's moving. The one at the extreme left and the one at the extreme right are moving in the same direction. But seizure can occur. Seizure in gear is just the total stoppage of the gear during movement. Okay, so this gear can stop and it's often caused by improper meshing or lack of lubrication. So if these gears are not properly lubricated, most likely it might seize. Or if the meshing is not properly done, it might also seize. Okay, so that is important that you lubricate the gears so that motion can continue and seizure can be prevented. Gears can also change direction. Look at the first one here and the last one here. They are moving in the same direction. Now, to avoid this last one to change direction, you need to insert what we call the Adler gear. This Adler gear is used to maintain same direction of the two gears at the extreme. So, this is the work of Adler gear to ensure that gears will maintain their same direction of motion. Without the Adler gear, as time goes on, these two gears might likely change their direction of movement. Okay, and we have different types of this gear. We have the spur gear, the helical gear, the rack and pinion gear, and the worm gear. This is spur gear here. In spur gear, the teeth of the gears are parallel to the shaft. Like they are designed in a way that their teeth are parallel to the shaft. Okay. While for helical gear, the teeth are inclined at an angle. The teeth are inclined at an angle to each other. If you take a closer look of helical gear, you find out that the teeth are not parallel to the shaft, but they are at angle to the shaft. And then we have what we call the rack and pinion gear. In this gear, you find out that the gear is running on a flat tooth rack. This is the tooth rack here, and the gear is running on it. So whenever you have gears that are in this form, it's referred to as the rack and pinion gear. And the last one is called the worm gear. The worm gear is just like the spur gear. It's just that it is made with a screw, as you can see here. The only difference is that you, instead of combining two gears together, only one, then merge with the screw. So these are the major four types of gears that we have in transmitting motion from one shaft to the other. Okay, there are some specialized type of gear too. We have the planetary gears. It is still combination of two or more gears, but they are merged with an internal gear. This internal gear here. Okay, so two or more gears now. This we have three gears here now. They are made together with an internal gear here. So together they are called the planetary gear. And the last one we call the bevel gear. The bevel gear is used for power transmission between inclined shafts. Okay, you can see that the two gears they are inclined at an angle. So you want to transmit power in an inclined form, the bevel gear comes in. All right. Then, what are the application of gear drive? Like we have said before, for transmission of motion. Gears generally are used for transmitting motion between inclined and parallel shafts. That's the major one. And they are also used in altering direction. If you want to change direction of movement, it is better you use a gear. So it is used in altering the path of motion. That is, it's used for changing direction. And lastly, it is used in selecting speed. You can use gear to select the rotational speed of your machine operation. So these are the three major application of gear: for transmission of motion, for changing of direction, and for selection of speed. So, talking about the speed, then what we call the gear ratio and the speed ratio. Gear ratio is just a term which means the ratio of the number of teeth on the driver gear, we target T1, to the number of teeth on the driven gear, which is T2. So gear ratio, which is capital G, equals to T1 over T2, that is number of teeth of the driver gear over number of teeth on the driven gear. However, for speed ratio, it is the opposite. Speed ratio is the ratio of the driven gear, which is the S2, over the ratio to the sorry, the ratio of the driven gear speed, okay, to the ratio to the gear speed of the driver gear, okay. So that's just what we call the speed ratio, okay. Ratio of S2 to S1, where S2 is the driven gear speed and S1 is the driver gear speed. So we can use the calculation to determine either the driver gear speed or the driven gear speed or even the speed ratio itself. Okay, so let's talk about a little on how to determine that. When we want to increase the speed of gear, it's important that we make it a compound gear. Compound gear can you see has two or more gear combined together and they give a faster speed. So how do you now calculate the speed of a gear, the driven gear or the driver gear, where the S2 represents the speed of the driven gear. So if you want to determine the speed of the driven gear, that will be the speed of the driven gear equals to the speed of the driver gear multiplied by the gear ratio, that is T1 over T2, where the T1 is the number of teeth of the driver's gear over number of teeth of the driven gear. So this formula is very key to determine the speed of the driven gear. So let's see one or two calculation, but then let's quickly look at one major gear that is used, okay, in transmission of motion, and that's called the bevel gel. When you want to change direction, actually, the bevel gel is the best type of gel you use. It is used in changing the direction of motion, okay, in an angular position. So it's very, very key in changing direction. Bevel gel plays the role of what? Changing direction in an angular power transmission. So now let's talk about how we can now calculate either the number of teeth on driven gear or number of teeth on driver gear or the speed of the driver gear or the speed of the driven gears. This is a typical example. Here we are told that the number of teeth on the driver and the driven gear is 12 and 16 respectively. All right. Now this 12 represents the number of teeth on the driver gear. Okay, that's what the 12 represents because this respectively means in that order. So the first one represents the first word mentioned here, that's the driver gear. So driver number of teeth on driver gear is 12. One number of teeth on the driven gear is 16. So it's noted there. Number of teeth on the driver gear, which is T1, that's 12. And number of teeth on the driven gear is T2. So we continue. We said if the speed of the driver gear is 100 revolution per minute, that is, speed of the driver gear, which is S1, is 100 revolution per minute. We have to calculate 1, the gear ratio, 2, speed of the driven gear. So remember that we are given some parameters here, number of teeth on the driver gear, which is T1, and that's 12. And we are given the number of teeth on the driven gear as well, which is T2, that's 16. We're also given the speed of the driver gear, which is S1, that's 100 revolution per minute. Now the first thing is to calculate the gear ratio. The gear ratio here is capital G, okay? And we also to calculate the speed of the driven gear. That's the S2 now. The speed of the driven gear is denoted by S2. So calculating the first one, the gear ratio by formula is capital G, which is the gear ratio equal to T1 over T2. Okay, and our T1 is 12, our T2 is 16, so 12 over 16. If we simplify it to the lowest form, you have it to be 3 over 4. That is, divide the numerator and denominator by 4. So you have 3 over 4 as the gear ratio. Then we have to calculate the speed of the driven gear as well. The speed of the driven gear is T1 over T2 times S1. And we know that T1 over T2 is our gear ratio. So our gear ratio, that's 3 over 4 times our S1 is given there to be 100 times 100. So if you do 4 divided by 100, that's 25. 25 times 3, and that will give us 75 revolution per minute. So these are the concept of gear drive system. And how to calculate the number of teeth of driver gear or driven gear, or calculate the speed of the driver gear or driven gear, and to also know type of gears that we have and the functions, their rules. Okay, so we shall be drawing the curtain here today. I hope you have learned something from the lesson today. Thank you for watching and have a wonderful day. Bye for now.